Hello, my name is Joanna Lemley. I am a wetland ecologist with the Colorado Natural Heritage Program. The following presentation will cover the second half of concepts needed to classify and describe riparian and wetland monitoring plots. You can follow along in section 5.1 and associated appendices in the field protocol for lentic, riparian, and wetland systems. This video, which is part 2, will include the hydrogeomorphic classification, general wetland types, and how the classifications tie together. Part 1, in a separate video, includes the general steps outlined in section 5.1 of the protocol and details on the coordinate classification. Hydrogeomorphic or HGM classification was developed in the 1990s by Dr. Mark Brinson as a tool for assessing the functions of wetlands. Some examples of functions or services that wetlands provide include water storage, water quality improvement, flood attenuation, stream flow maintenance, carbon storage, wildlife habitat, and many others. These functions are more closely related to where the wetland occurs in the landscape and how water moves through it than whether the wetland is dominated by herbaceous or woody vegetation, as described in the coordinate classification. The primary considerations when applying the HGM classification include the geomorphic setting, the water source, and hydrodynamics, meaning the rate and direction of water flow. There are 5 main HGM classes, each with 2 or 3 subclasses. The classes are slope, depression, riverine, lacustrine fringe, and flats. Appendix I of the Field Protocol for Lentic, Riparian, and Wetland Systems contains a key to the 5 main HGM classes and detailed descriptions of each class and their subclasses. The following slides will walk through each of the 5 classes in the order they are presented in the key in Appendix I, which starts with the less common classes first. You can follow along in the appendix. The first couplet in the HGM key is for flats HGM class. These expansive wetlands are essentially flat. The dominant water source is precipitation falling directly onto the wetland and maintaining soil saturation. These wetlands receive essentially no groundwater discharge. Instead, they feed groundwater aquifers, and they do not connect to water bodies. The hydrodynamics, meaning the direction of water flow into and out of the site, are primarily vertical fluctuations. Precipitation falls directly on the wetland, and water is lost through evaporation up and, to a lesser extent, infiltration down. These sites are restricted to very wet environments, like Alaska, the Pacific Northwest, Upper Midwest, and the Southwest, where extensive precipitation can sustain soil saturation. They are uncommon in the arid West and Rocky Mountains. Just because a topography is flat does not mean a site fits the flats HGM class. Consider whether the local climate supplies enough direct precipitation to sustain soil saturation for weeks or months at a time. There are 2 subclasses to the HGM class, mineral soil and organic soil flats. These are based on the dominant soil type. Bogs, precipitation-fed peatlands, are an example of organic flats. The second couplet in the HGM key is for lacustrine fringe HGM class wetlands. If you remember from part 1 of this presentation, the word lacustrine is also used in the coordinate classification. But in coordinate, the lacustrine system is for lakes themselves and their non-vegetated shores, not vegetated wetlands adjacent to lakes. In coordinate, all vegetated wetlands with rooted perennial vegetation are in the palustrine system, regardless of where they are located. In the HGM classification, in contrast, the lacustrine fringe class is used for wetlands that are located adjacent to lakes larger than 20 acres and are hydrologically connected to the lakes via surface or subsurface connections. To drive this home, an herbaceous wetland located adjacent to and influenced by a lake would be called a palustrine emergent wetland in coordinate and a lacustrine fringe wetland in HGM. Lacustrine fringe wetlands are not only adjacent to lakes, but strongly influenced by them. They may experience wave action and rising and falling water levels tied to lake levels. The hydrodynamics are driven by bidirectional flow of rising and falling levels. When classifying wetlands adjacent to lakes, make sure to consider other potential water sources. Especially at higher elevation, groundwater can discharge from slopes surrounding lakes, and may be a more dominant water source than the lake itself. To be classified as lacustrine fringe, remember that the hydrology must be directly tied to the lake. There are two subclasses to the lacustrine fringe class, natural and reservoir. Large lakes and lacustrine fringe wetlands are not common on BLM public lands. The third couplet in the HDM key is for riverine wetlands. Riverine wetlands are very common on BLM public lands. Like lacustrine, the word riverine is also used in the Coarden classification. But in Coarden, the riverine system is for the rivers themselves and their in-channel gravel and sandbars, but not vegetated wetlands associated with rivers. In HDM, the riverine class is for wetlands located on floodplains and in riparian corridors. The dominant water source is the direct connection to the river or stream via overbank flooding, backwater flow, and a connection to the alluvial aquifer or the local groundwater aquifer. Riverine wetlands experience flooding at least every 5 years, but it can be longer for drier, non-wetland riparian areas that are disconnected from their stream channels. The flow in riverine systems is horizontal and unidirectional, meaning movement primarily flows along the river gradient. Riverine wetlands are influenced by high-energy stream systems that move sediment and nutrients through the landscape. Riverine wetlands are usually natural, although wetlands formed along ditches and canals do count as riverine. And there are two subclasses, floodplain and beaver-impounded. The following slides show photos of riverine wetlands associated with river and stream systems. Some riverine wetlands are located in stream valleys that are narrow and confined, while others occur on broad floodplains. The floodplain subclass can be used for all riverine wetlands on large floodplains and even in riparian corridors without beaver influence. Beaver-impounded subclass can be used for riverine wetlands influenced by beaver. Many, if not most, streams in the West once supported beaver before widespread trapping in the mid-1800s. The fourth couplet in the key is for depressional wetlands, which are relatively common on BLM public lands. These wetlands are located in topographic depressions that hold standing water. Potential water sources for depressional wetlands include precipitation, surface water runoff, stream inflow, or groundwater. Water flows into depressions from higher elevations in the surrounding landscape and towards the center of the depression. The outflow is generally restricted except in times of high water. In the West, there are both natural depressions and depressions formed by excavation and human-made impoundments. There are two types of depressional subclasses, open and closed. Open depressions are connected to other wetlands or water bodies through some form of channelized flow. In the photo on the left, the depressional wetland was connected to other wetlands in the small pond through culverts under the road. The photo on the right is a closed depression formed in an abandoned oxbow, now located far from the active river channel. This slide and the next show example of natural depressional wetlands across the West, including playas and some ponded features. Depressional wetlands, especially playas, can be saline, with salt deposits on the surface. There are also many non-natural depressions formed by impoundments and excavation. The last couplet in the key is for slope wetlands, which are also very common on BLM public lands. Slope wetlands are located at the base of slopes or in association with seeps and springs. The dominant water source for slope wetlands is groundwater discharge. Additional sources may be specific point source springs, surface water runoff, or snowmelt. The flow in slope wetlands is downslope and unidirectional, but unlike riverine wetlands, there is no major channel formation, though there may be small channels that coalesce and feed into low order or high order headwater streams. In addition, slope wetlands can occur on the margins of stream valleys where groundwater discharges to the edge of the valley. In these landscape positions, there is a transition from slope wetland on the edge of the valley, sometimes at slightly higher relative elevation, to riverine wetlands directly affected by the stream. Slope wetlands can also occur in narrow valleys with no clear stream channel. There are 3 slope subclasses: topographic, stratigraphic, and vegetated drainageway. Topographic slope wetlands occur at the base or the toe of slopes, where groundwater discharges to the surface. The topography of these sites can be relatively flat, but they are still considered slope wetlands and not flats if they are driven by groundwater discharge. Topographic slopes are a common subclass of slope wetlands. Fens are a common slope wetland that form at the base of slopes with high groundwater discharge. Fens have deep organic soil that is a sign of perennial groundwater discharge. Slope wetlands with more seasonal groundwater discharge can also form wet meadows, which are drier than fens and don't have thick organic soil. At high elevations, wet meadows can also be fed by snowmelt. Stratographic slope wetlands occur on the side of hills where springs emerge. They can be quite steep and are generally smaller than topographic slopes. The third slope subclass is vegetated drainageway. These are narrow linear features fed by groundwater discharge, springs, and surface water runoff. With that understanding of the coordinate classification from part 1 of the presentation and the 5 major HGM classes from this presentation, we will now walk through the general wetland types, which are found in Appendix J of the protocol. These types use colloquial names for riparian and wetland systems that should be recognizable. They integrate concepts from both the coordinate and the HGM classification. As I describe each one, I will note how each general wetland type might be classified in the other 2 systems, as well as mentioning potential water sources. Wet meadows are herbaceous wetlands dominated by graminoids, including sedges, grasses, and rushes. They have mineral soil that may have high organic matter, but not enough organic matter to classify as a true deep organic soil. They are found widely throughout the West in many different settings and elevations. Water sources can include regional groundwater, local floodplain groundwater, and overbank flooding if found on a floodplain, overland flow, snow melt, and even irrigation runoff. In the coordinate classification, they are considered palustrine emergent, or PEM. They can have coordinate water regimes of A, temporarily flooded, B, seasonally saturated, C, seasonally flooded, or E, seasonally flooded and then saturated. The HGM classification is typically slope if they are groundwater fed, or riverine if they are on a depression, or on a floodplain, sorry. Marshes are wetlands with relatively permanent standing water that support coarse emergent plants like cattails and bulrushes. These have higher standing water than wet meadows, and the dominant species are adapted to the higher water. Water sources can include regional groundwater, seeps or springs, local floodplain groundwater and overbank flooding if on a floodplain, overland flow, and irrigation return, or seepage. In the coordinate classification, they can be PAB, or palustrine aquatic bed, if they are rooted floated vegetation, or PEM, or palustrine emergent, if they are herbaceous vegetation. They can have coordinate water regimes of C, seasonally flooded, D, permanently saturated in some instances, E, seasonally flooded and then saturated, or F, semi-permanently flooded. The HGM class is typically depression, or riverine if they are in a floodplain, or slope. Riparian shrublands, woodlands, and forests are woody wetlands or even drier riparian areas. They often occur on floodplains, but can also be on the margins of lakes. They can even occur on slopes that have enough discharge to support woody vegetation. They can be true wetlands with hydric soils, or they can be drier, non-wetland riparian areas. Water sources include overblank flooding and local floodplain groundwater, lakes or reservoirs, and regional groundwater. In the coordinate classification, they are either palustrin scrub shrub, PSS, or RPSS, riparian scrub shrub, if they are dominated by shrubs, or palustrin forested or RPFO, riparian forested, if they are dominated by trees. They can have coordinate water regimes of A, temporarily flooded, C, seasonally flooded, and E, seasonally flooded then saturated. The HGM class is typically riverine, but can also be lacustrine fringe or slope. Fens and bogs are wetlands with organic soil and permanent saturation. Fens are groundwater fed and bogs are precipitation fed. Bogs only occur in places where precipitation can maintain permanent saturation, like Alaska. Water sources include regional groundwater discharge, seeps and springs, and precipitation, but only for bogs. In the coordinate classification, they are either PEM, palustrin emergent, PSS, palustrin scrub shrub, and occasionally PFO, palustrin forested. The only coordinate water regime is D, permanently saturated. That is the defining characteristics of fens and bogs. The HGM class is typically slope, but can be depressional or flats in Alaska. Vegetated drainageways are narrow linear wetlands formed in drainages. They can have small channels, sometimes as a result of trampling. Water sources are regional groundwater, seeps and springs, and surface water runoff. In the coordinate classification, they are either PEM, palustrin emergent, or occasionally PSS, palustrin scrub shrub. They can have coordinate water regimes of A, temporarily flooded, B, seasonally saturated, and C, seasonally flooded, and occasionally D, permanently saturated. The HGM class is always slope. Prairie potholes and vernal pools are three similar wetland types that occur in different regions in the West. They are all ephemeral or temporary depressional features. Playas can occur throughout the Intermountain basins and out onto the Great Plains. They can be saline or not, depending on water source and underlying geology. Prairie potholes are depressional wetlands formed by glaciers in the upper northern Great Plains. Vernal pools are seasonal depressions in the Pacific Coast states of California, Oregon, and Washington. Water sources include precipitation, surface water runoff, snow, and regional groundwater. In the coordinate classification, they are palustrin emergent, or PEM. They can have coordinate water regimes of J, intermittently flooded, A, temporarily flooded, B, seasonally saturated, or C, seasonally flooded. They are always depressional HGM class. The general wetland type of spring or seep is reserved for wetlands formed around a localized spring or seep that do not meet the criteria of larger wetland systems. Water sources include seeps or springs and regional groundwater. In the coordinate classification, they are typically PEM, palustrin emergent, or occasionally PSS, palustrin scrub shrub. They have coordinate water regimes of B, seasonally saturated, C, seasonally flooded, or D, permanently saturated. They are always slope HGM class. This slide contains a flowchart that can be used to guide you through the general wetland types. The questions emphasize the key aspects of each type that differentiate one type from another. This flowchart will be available to you during training. I'll give you a moment to look at it. This slide contains a table linking general wetland types to coordinate water regimes. This table will also be available during training. This concludes part 2 of the presentation on classification and description. Thank you for listening.